Hi everyone, my name is On Cow. This semester in ENME 435, I used a Raspberry Pi 4, a camera, a laser, and Python programming to create a 3D scan of a parking meter. Early in the semester, one of our very first assignments, we used skills such as color masking and using upper and lower bounds to circle and track a green light on a traffic light. Next, we moved on to lane detection and a Ring doorbell project. Here we masked images using thresholding, detecting colors, and changes in pixels. And we also delved into pixel manipulation, noise application, and filtering techniques. We learned how to manipulate pixels, apply noise to an image, and filter it out. Familiarizing myself with the Raspberry Pi system and camera was a great accomplishment this semester. From this class, I learned the intricacies of capturing images through Python and gained a foundational knowledge on how LiDAR technology operates. In lecture, we learned that LiDARs have many applications. For example, is used by aircrafts to scan ground topology and also used in self-driving cars to detect things such as lanes, road signs, obstacles, pedestrians. LiDARs became a significant focus in this class, and for my final project, we were able to integrate all of these skills to create a LiDAR system and choose an object to scan. I chose a parking meter as my object of interest, and that's because I thought it'd be a really cool thing to 3D print. In my LiDAR system, the Raspberry Pi handles the data collection. It's basically the main system that interprets what is being transmitted and received. The laser, which is the transmitter, and it's also powered by the Arduino, and the Raspberry Pi camera, which captures the images, which makes it the receiver. Those three is what makes up this LiDAR system. As demonstrated in class, the laser emits a beam onto an object, and the Raspberry Pi captures an image, and we measure the displacement from the center line, which is a feature that we've programmed on Python to appear on the captured image along with a number. Using an app on our phones, we collect IMU, which is short for inertial measurement unit. It allows us to track how many degrees the LiDAR system rotates while it's on the tripod. And this helps gauge the distance of the laser. The points closest to the laser indicate our object, and we compile all the collected points into a point cloud to generate a 3D scan. So here are some of the images of me calibrating my scanner. The calibration involves taking measurements at set increments away from a solid wall to adjust RPC values and row values within the Python code, ensuring that we are collecting these images at an accurate distance, or accurate distant measurements for the laser line. So in these images, I was taking photos of the laser onto a Promethean screen in my room that's in our apartment complex, and yeah. Additionally, something important that was shared in class was this equation, which includes key variables to create a point cloud. That is d equals h over tan theta, which is distance from target equals distance between transmitter and receiver over tan theta, where theta represents the radians per pixel pitch plus an offset value times the pixels from center. Considering that at first when I calibrated my laser and adjusted the row and RPC values, I didn't have a tripod and the laser was unsteady, I tried to adjust my values as best as I could to fit the calibration curve, and this is what I got. Last time I tried to scan that thing over there, the lamppost was really throwing it off. So we're going to be scanning this parking meter in 3 different locations using that tripod thing to capture images at increments of 1 degree. So all the way around 15. But yeah, so the first scan that I had was actually right here. I just didn't record it. This is my second one, and I'll be wrapping up the third one. So hopefully it'll scan something nice. So this is after I converted all of the JPEGs into a text file. 3 text files for 3 different scans, and each of them is of a parking meter. After I had readjusted the coordinates so they all kind of create the 3D model of the parking meter. For that, they were all in different locations. So for example, this is what it was before. So in order to align it, what I had to do was I had to mess around with the translation coordinates and then the rotation. Definitely with the lamppost on top, it made it really difficult to have a cleaner shot of the back face of it. In the future, I would probably try to mess with the exposure so that it would capture the red laser better. Interesting shape. I went to normals, curvatures, and orientation, and I clicked on compute normals for point sets. And then I just clicked on apply. I just searched up Poisson disk sampling and clicked on apply. Unfortunate news is that it kind of looks like a piece of popcorn.